Okay, let's look at the rational exponent form of an expression versus the radical form. And as an example, we'll take 8 to the minus 4 thirds. Now if we were going to put this in the rational exponent form, we've got a negative exponent. So first thing I'll do is I'll put 1 over 8 to the positive 4 thirds. And then from there, again I'm using exponent form here. From that I can take and go 1 over 8 to the 1/3, and that whole thing to the 4th power. Now 8 to the 1/3 would be 2. 2 is the cube root of 8, and then to the 4th power, which would be 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. And of course that's in the bottom. I lost track of that fact. So really we got a 1 over that. 1 over that. So we have a 1 over 16. So here we did this with rational exponent form. So now let's look at it with radical form. So we have 8 to the minus 4 thirds. And that would be 1 over the cube root of 8, and that quantity to the 4th. Here we have it in radical form. So we can take the cube root, I should have put the 3 there, like so. So 8 to the cube root. So we have 1 over, the cube root of 8 is 2, it's to the 4th. So we have 1/16 again. So we arrive at the same solution either way, but this way we're sticking with exponents throughout the whole process. And this way we take and we put 8 to the 1/3, we put it as a cube root, and then to the 4th power. So this is the radical form, and this would be in exponent form. Let's see if we can find another example. Some examples of rational exponent notation. We'll take 7 to the cube root, and to put that in exponent form, we would have 7 to the 1/3. That would be the rational exponent form of that. Another example, we could take 14 to the 5th root, and all that to the 4th exponent. So now to put that totally in exponent form, this 14 to the 5th would be 14 to the 1/5, and then to the 4th power. And we can take 4 times the exponent when we take a number with an exponent to the 4th. So we have 14 to the 4/5. That would be another rational exponent form. Let's see if we can do a couple with the radical notation. We take 17 to the 1/3. Radical form, we'd just say cube root of 17. Another example, 33 to the 2/3. Well, 1/3 would be cube root, so we can say the cube root of 33, and then 2, that part would be squared. Another example, minus 28 to the 7/5. Okay, the 1/5 would be the cube root, not cube root, I'm sorry, the 5th of minus 28. And remember, when we have an odd root, then it's okay to have a negative number inside the radical. And then we take that whole thing to the 7th. So those are some examples of rational exponent form and radical form.